It's important that we memorize the triangle of the formula. So for average velocity, the formula that we have, the triangle that I gave you, is this one. Okay. Where here you have velocity, here you have the time, and here you have displacement. Remember this. Displacement is delta x. Time is delta t. Okay, so in the first, well, I'm not gonna do the first one actually. Well, I'm not gonna do any of them, okay? But, okay, I'm gonna focus on the number 2. But I'm going to change the givens, okay? I'm gonna change the givens because I want that you do all your homework. So it says, if Joe rides his bicycle in a straight line for 22 minutes with an average velocity of 12.5, this value I'm also going to change it because I need that you also practice conversions, okay? 16 kilometers per hour south, how far has he ridden, okay? Now, take a look. You need to identify givens. We can possibly have 3 givens. We can have displacement, we can have time, or we can have velocity for this topic, okay? So, if the problem gives you minutes, remember, we measure time in minutes, seconds, days, years, okay? So if you see minutes, that means that the problem is giving you the time. So you come and write your givens. Delta T is 22 minutes. But as I told you since first day of classes, we need to always make the conversion, okay? So if I give you minutes, you need to convert to seconds, okay? The conversion factor between minutes and seconds is in 1 minute, you have 60 seconds, okay? So where are you going to write the minutes?
Down.
Down.
Minutes are written down. 1 minute, 60 seconds. So that means that you will multiply because these two are in the top side of the fraction, okay? Now, how much do you get from this?
1,320.
1,320.
320.
And these are going to be seconds because minutes and minutes are going to be canceled. The other data is, it says that Joe, during those 22 minutes, he drives with an average velocity of 16 kilometers per hour south.
The answer that first given of displacement have to always be in seconds.
Displacement is displacement is measured in meters. So
yeah, but it have to be always seconds, the answer.
For the time, yes. So as I told you the other day in class, you have to recognize those values that you have to convert. For example, in the first one, the one of Heather and Matthew, they are giving you time in minutes. So you also need to convert to seconds, okay? Now, in the case of the velocity, they are giving you meters per second. So in this case, you don't need to convert. You can use this value. But the minutes, yes, you will have to convert them. Now, the other given in this problem, the number 3 is the average velocity. Average velocity, that is average velocity, VAVG, equals 16 kilometers per hour south. I need to turn this velocity into meters per second. So what I do in the first place is I'm going to write it in the form of a fraction. Just in a separate sheet of paper. 16 kilometers per hour, okay? This, you're gonna write it as a fraction. Kilometers in the top, the 16 and the kilometers are in the top. Okay, and the hours in the bottom. So, remember the procedure that we do to convert kilometers per hour to meters per second. I need to write my kilometers down. How many kilometers? How many meters are in 1 kilometer?
1,000.
1,000 meters. You cancel kilometers with kilometers, and we continue. Take a look. Hours are in the bottom, so I need to write my hours in the top. How many seconds do you find in 1 hour?
3,600.
Okay, 3,600 seconds. So you get rid of with hours and hours, okay? Now, this gives you how much?
4.44.
4.444. Okay, so 4.44. We don't need to round it because the next number is 4, okay? So these are gonna be meters from the top and seconds in the bottom. So you have time given and you have velocity given. The problem is asking you to find how far has he gone, okay? How far? So it's because the problem is asking you about how far, that means that you need to find displacement. How far? ¿Qué tan lejos? Okay, so it is a distance, and distance is a kind of displacement. So how far? That means that we need to look for displacement. Now, in the triangle that I gave you, this triangle, what do we do if we need to isolate for displacement? What do we need to do if we need to isolate for displacement?
Multiply velocity times time.
Exactly. So you take your displacement, you take it, and you're just gonna use the remaining of the formula, which is velocity and time. And because these two are together next to each other, they are multiplying. So you say delta x, or displacement, is going to be equal to velocity times delta t. Velocity, you're going to use the value already converted, that is 4.44 meters per second. And you will multiply times the time. The time already converted is 1,320 seconds. With this, you can see that seconds, okay, are in the top and they're going to be canceled with these seconds in the bottom. So delta x is equal to what?
5,860.8.
5,860.8. And what unit are we going to write? The unit for displacement that are meters. Meters, okay? And with this, you finish your problem. This exercise number 3 is going to help you to solve, the number 2 is going to help you to solve the number 1, 2, and 3, okay, from the page 40. because they are very similar. Because you're looking for the same thing. In the three of them, you're looking for displacement. So basically, all you're gonna do is the same. You're gonna apply the same formula, the same isolation process. If you need to convert, you will do it. If not, go straight to the formula. With the number 5 from page 45. Let me see. Let me bring it. Okay, this one is average acceleration. This one is number 5 from the page 45. In page 45, we have average acceleration. As I told you, I cannot do the same exercise. Let me see. You know what a treadmill is? Guys, do you know what a treadmill is? It's like una caminadora, okay? Okay. So let's see. I'm not gonna do it. I need to change the givens. Wow, beautiful change. So it says, suppose a treadmill has an average acceleration of 4 times 10 to a negative third power meters per second squared. How much does its speed change after 7.5 minutes? If the treadmill's initial speed is 1.7 meters per second, then what will its final speed be? Okay, so in this problem, I know it is average acceleration. So because I know the topic, I'm going to write, the first thing that I will do is my triangle, because the triangle is going to tell me exactly what I need. For average acceleration, I need time, I need change in velocity, and I need acceleration, okay? So in the case here, they are giving me the acceleration, okay? That is 4 times 10 to the negative third power meters per second squared. And I know it's acceleration because the problem is telling me it has an average acceleration of. So my first given here in this example is going to be my acceleration. That is 4 times 10 to the negative third power meters over second squared. In part A, they are asking me to find how much does its speed change after 7.5 minutes. So it's given me time. Okay, it's given me time. So they are giving me a time of 7.5 minutes. I know that I have to do the conversion for the time. So my conversion is going to be, in 1 minute, I have 60 seconds. This gives me 450 seconds. okay? So I have the time, and in this part A, it's telling me how much does its speed change after 7.5 minutes. Remember that I told you the other day that speed and velocity, they are not the same, but they are not exactly the same, but they are very close, okay? They are very close. Here, because the problem is not mentioning any direction, that's why the problem says speed. And when it talks about speed, it's about velocity. But the problem says a very important word that says speed change, change. Remember that anytime we talk about change, we talk about delta, okay? So when we talk about speed change, it's like saying velocity change. And how do we write a velocity change or a change in velocity? Change is delta and velocity is v. So delta v. The problem is asking me, what is delta v? This is going to be my unknown in the part A. I don't know what delta v is. Okay, so I need to find it. And in the part B, it says that if the treadmill's initial speed is 1.7 meters over second, what will its final speed be? So in here, they are giving me initial velocity. Initial speed is going to be like the same as initial velocity, okay? So speed initial is going to be velocity initial. And to express velocity that is initial, we say VI. VI is equal to 1.7 meters per second. And then the problem is asking me, what will its final speed be? I need to find the final speed. So I need to find the speed final. Because we're talking about speed, we can say that is the same as velocity final. And we express this as VF. And VF is going to be unknown. So that's how you write your givens for the problem 5. Now, what comes after? We start working with the exercise, okay? So in the first part, I need to find delta V, the change in velocity, okay? So that is what I'm gonna do right now. I'm gonna work here beside. So for part A, I want to know delta V. If I want to know delta V, I will use my triangle, okay? So what is the formula that I'm gonna use for delta V? It's going to be what is left from the triangle. Remember, you remove the value that you have, okay? You remove it, you don't use it. Instead, you will use the remaining of the triangle. In this case, is the bottom part. And in the bottom part, you have acceleration and time. And because they are together next to each other, they are multiplying. What do you need to do after? To see if you have everything you need. We have acceleration. Yes, we have acceleration. We have the time. Yes, we have the time. So all we do is substitution. So we say acceleration, that is 4 times 10 to the negative third power meters over second square, multiplying the time, that is 450 seconds. So one of this second is going to be canceled with one of these seconds. So my change in velocity is How much do you get?
1.8.
1.8. Now you're going to write the units, okay? We have meters in the top and we have 1 of the seconds. We cancel only 1 of the seconds of the acceleration, but 1 second was left. So we write the units, meters per second. In part B, it says, if the initial velocity is 1.7 meters per second, what is going to be the final velocity? So, okay. So in this case, what we need to do is we need to analyze, we need to isolate for the final speed. Okay. So let's see. Okay. First, we need to understand where do we find final velocity? How do we find the final velocity? Okay, we know that change in velocity is equal to, we know this formula, okay? But don't get confused. We know this formula that is acceleration times time. Now, to find delta V, we also have another formula that I gave you the other day. From this triangle, we know the velocity is delta x over delta t, okay? Now, we also have another formula for velocity.
Delta time
Change
dividing delta displacement.
Delta time over delta, no. To find the velocity, take a look. Here, the problem is not giving me displacement, okay? The problem is not giving me displacement. So what should we do? I'm gonna write the other triangle right here. What happens here? In this part, we have a final velocity, okay? That we need to find. And then we have an initial velocity of 1.7 meters per second. Now, we have one equation for delta V. If you need to isolate for delta V, this is what is remain, okay? That's what is remain. But delta X is not given the problem. So what can we do? The problem is giving me time, okay? And it's giving me a change in this one. So this is it. Do you remember this equation? This is the first equation that I gave you for velocity, okay? Now, I'm looking for final velocity, okay? Now, if I want to isolate final velocity, take a look. I already have delta V. I already have the initial velocity. So I need to isolate BF. I cannot use this first triangle for one reason. I don't have delta X, okay? That's why I cannot find it. So I have to look for another formula. In this case is delta. The main definition of change in velocity. Change in velocity is equal to BF minus initial velocity. So we say delta V. If I want to isolate BF, that means that I need to remove this part of the equation that is subtracting, okay? And I have to send it to the other side of the equation to make an addition. So we say delta V plus initial velocity. It was subtracting and it went to the other side to add. From subtraction to addition. Then I write the rest of the equation. This is equal to BF. This is the isolation that I'm using to find BF, okay? So delta V, I got it from the part before, 1.8 meters per second. Plus initial velocity is given me in the part B of the problem. That is 1.7 meters per second. The addition of the two is gonna give me the final velocity. How much is this?
3.5.
3.5 meters per second. You can write the answer like this or like me. I prefer to write BF in the left, which is the one that the part that I want to find. And I like to write the definition in the right side. I don't know, I'm having a problem with this iPad. Yeah. So if you cannot use a formula, okay? Because for example, here, you wanted to look for BF and you didn't have like the proper formula for it. Imagine that you go and look for this triangle. It might be useful sometimes, but this time it wasn't. The reason is because the displacement was not given in the problem. So we don't use it. What do we use instead? The main definition of change in velocity, which is final condition minus initial condition of velocity. The isolation process, BI was subtracting, it goes to the other side to add. Once you add the two of them, you get the right answer. Efraín?
Mission in some cases we will use it to get the velocity, the initial velocity or no?
Yes, you can use the same formula to use the initial velocity, but the problem has to give you something else. For example, the final velocity. Okay, the problem has to give you everything you need or everything that you could need in another formula to get exactly the value that you need. Sometimes you have to use many formulas. Here you are using just one formula, two at most. But there are others that you have to use like 3 formulas in the same exercise. So I hope that you can make corrections if you have corrections to do in your homework. And study for Monday that we have a quiz.
Miss, for when is this homework?
For when?
Is this homework, what date?
Bueno, you can take it to me on Monday, but I want you to study, okay? I want you to study.
Okay.